Okay, are you guys ready for some algebra? This is our first section of content, and in this video we're going to start with section 1.1, but we're only going to cover about half of it, and then we'll do the rest in another video. So today we are going to look at the Cartesian coordinate system, and with that we are going to talk about ordered pairs, using a graph to represent relationships between two numbers, and also graphing equations. And then we'll stop, and then in the second video we'll cover the rest of the topics that are in this section. Okay, so let's start. So Cartesian coordinate system. There's a sample down here at the bottom of this page of what this is. We're going to walk through why we have one and what it's used for, but this is an example of a Cartesian coordinate system. And this is used to show relationships between values. So up here in the first sentence, hopefully you found this handout and were able to print it off or at least have it up on your screen. I would really recommend printing these out and filling them in as we go. Whenever we have problems to work, there will be space for you to work those. And then there's also just lots of room in the margins that if there's other things that you want to make note of, you can do that. And it's really helpful when you're studying and also as you're doing homework. Okay, and I'm just getting used to this program, so forgive me if things don't look quite as neat as hopefully I'll get better at it. But for this first sentence, we use a coordinate plane to graph a pair of numbers. And so that is Cartesian coordinate system is this whole idea, and then this picture down here is actually a coordinate plane. So it is two-dimensional. It's representing points that are on a plane. So like a piece of paper, a wall, or a floor. There's nothing three-dimensional, so that we don't have anything coming out at us or going back into behind the paper. To locate points on a plane, we use two perpendicular lines. You can see those here. These two lines that meet at a right angle are the perpendicular. And those are the x-axis and y-axis. The plural of that is axes, so that's what goes in this blank. We use two perpendicular lines called axes. These lines intersect at a point where both values are 0. So again, this is representing two numbers, a number that we're going to represent with x and a number that we're going to represent with y. So this x-axis is a way to show what value we have for x, and the y-axis values for y. The point right here in the middle, I'm going to put a blue dot there, that is the origin. So that's what goes in this next blank. And that does represent the place where x equals 0 and y equals 0. And notice this right here in this sentence when it's, oops, I'm in the wrong place, right here. It's representing that point where x is 0 and y is 0 with an ordered pair. And we'll get to that in just that definition in just a minute, but you can see it has the 0, 0, and they're in parentheses. That is standard notation. So that is how we want to represent whenever we know the value of x and we know the value of y, and we put those together. We use a comma in between and we put parentheses. The x value comes first. In this case, they're both 0, so order doesn't really matter, but just know anytime that we have an ordered pair, that first number is the value for x, the second number is the value for y. Okay, next sentence. The horizontal axis. Horizontal is like horizon, so think of the line where the sky meets the ground. That is going back and forth, left and right. That is the horizontal axis. It's called the x-axis, and the vertical axis is called the y-axis. And you can see those labeled in the picture below. And again, I'm getting used to this program. Sorry, I kind of missed the blank there. But the blanks there are x-axis and y-axis. The axes divide the plane into 4 regions, and you can see that here. See the four spaces? And by the way, these axes keep going, so it continues to divide that plane. Sometimes when you're graphing points, Depending on how you've drawn your graph, you might find out the point ends up way out here, and that's okay. This keeps going even though it's not marked off after, what is that, around 8 or so. It keeps going out like this, and the y-axis keeps going. So it really divides this whole piece of paper into 4 regions, and those are called quadrants. So that's what goes in this blank. And the numbering for these is specific. It's standardized. This first quadrant is the one that's in the top right-hand corner. And a way to remember that is when both x and y are positive. So our x-axis is how far you go to the left or the right. We've talked about this first point being 0, the origin. So x is 0 there. But anytime you go to the right, you are going to have a positive x. So if it's on this line right here, it's going to be a positive 1, 2, 3, 4, 5. So positive numbers to the right, and then just the opposite, this direction, are negative. So negative 1, negative 2, negative 3, and so on. Y is how far up and down on the y-axis we go. So 1, 2, 3. These are positive going up and negative going down. So let me just put a little plus here for our positive x's, our negative x's, positive y, negative y. So when we're in this first quadrant, both x and y are positive. So that's why that's our first one. So if that helps you remember which one is quadrant 1, it's when they're both positive. So it's at top right. And then we go counterclockwise. So this section right here, which is the top left, the y is positive, x is negative, and then quadrant 3 is down here. Both numbers are negative. In quadrant 4, the x value is positive and the y is negative. Okay, so that's our first page of notes. An advantage of doing videos like this is that you can pause, you can review, you can rewatch. The disadvantage is that you don't have a chance to ask questions. So do keep in mind I am available. Whoops, let me pull that back up. Okay, just keep in mind that I am available through email. And really, if you have questions about the material, I really think our discussion boards are the right place for that, because there's probably someone else that has that same question, or our office hours. Because again, those are open to everybody, and the questions you have probably will help somebody else. Okay, let's keep going. Each point, I've already used these words. So ordered pair. Each point is called an ordered pair. It's described by an ordered pair. And that is, like we were talking about before, that's those numbers that have the x value and y value separated by a comma and in parentheses. And we have some examples of those just right down here. We're going to be doing some graphing of some points right here. The first number is represents the horizontal location, and it's called the x-coordinate. And again, we've already shown this. So like we said before, the first number represents how far to the left or right, and that is our x value. The second number represents the vertical, so how far up or down you go, and that's called the y-coordinate. Okay, let's graph some points. So first value is our x value, or our horizontal. Again, x is this horizontal line. So we're going to go 2 to the right. So starting at the origin, go 2 to the right. And the y value is negative 4. And since it's negative, we're going to go down 4. 1, 2, 3, 4. So just get into your head that the x is what comes first. That's how far left to the right. So the 2 is 2 to the right since it's positive. The second number is the y value, so we go down 4. So there's our first point. Now, one thing I want you to get in the habit of, and this semester, since I'm not going to see as much of your work as normal. Normally, quizzes and tests would definitely be all paper. We're going to work through that. We're going to be doing a lot more on the computer with our quizzes and tests than normal because of COVID, but I want you to get in the habit of always labeling points like this, because this graph, even though probably most people by default would say that each of these spaces between the lines count as 1, we really don't know that unless you label them. So you can label them in a couple different ways. You could go up here on the x-axis and actually label a few. My pen is kind of fat here, so you can't really read my numbers too well, but if you were doing this on paper, you could label, you know, that first section is 1, 2, 3. You'd also have to do it on the y-axis because sometimes those represent different things. For example, you could have every single one of those lines represent 2. So instead of this being 1, 2, 3, it'd be 2, 4, 6. Or you could have it's counting by 5, 10, 15. And when we get to the graphing calculator and start doing some problems, you're going to see there's times where you really have to do that in order to have it fit on the screen. So you do want to label, and so you can label your axis, or once you make your point, you can label your point. And that's probably what I would do in this case, is I would just label my point rather than all of these numbers on the axis, because that's getting kind of cluttery. Okay, so our second point is, switching pens here. I'm going to get better at this, I promise. 0, 6. So our x coordinate is 0. So that means we don't go to the left or the right. We're going to be right here in the middle. And notice we're right here on this line. And then 6. 1, 2, 3, 4, 5, 6. There's our second point. And then -2, -3. 2 to the left, because that's our first coordinate. -3 is right down here. And again, I would label these. And in fact, if you are taking a written test or quiz and you don't label, if you just put dots there, you're going to get some points taken off because you really haven't shown me what that point is. So just get in the habit of labeling your points. Okay, let's move on. Okay, moving on. So down here at the bottom of page 1, graphing equations. So first of all, before we can talk about graphing equations, let's talk about what an equation is. An equation is a sentence in math, and it has an equal sign. So that's what goes in this blank. And an example of one is right down here at the bottom of the page. Right here is an example of an equation. Notice that it has some numbers, variables. Variables are the letters. And then the important thing to make it an equation is the equal sign. So that's what makes this an equation. You can see the word equal is almost in the word equation. And whenever we're talking about graphing, we are looking for solutions. What is a solution to an equation? A solution to an equation with two variables is an ordered pair that makes the equation true. So if we had an x and a y value that made that equation true, if we substituted and replaced each of the letters with the value from the ordered pair and it makes a true statement, then we know that it is part of the solution. So let's just take a look at this example here. We want to check our first ordered pair, which is 3, -1. There's three. This basically is 3 separate questions. We've got the first ordered pair. We're going to check to see if it's a solution. Then we'll check the -4 or -1, 4, and then 0, 3. So some of these may be solutions and others not. So out here to the side, I'm just going to rewrite this equation, but instead of the x, I'm going to put in 3. And instead of the y, -1. And hopefully you know that whenever you have a number and a variable written right next to each other like this, 4x, that means 4 times x. We just leave that multiplication sign off. And so when I'm substituting and replacing the x with our value of x, which is 3, I'm going to actually show that it's multiplication. Now, a lot of times, probably the way you were taught is to use a x for multiplication when you first learn to multiply. As we get into algebra, we a lot of times replace that with a dot just because we're using x's as variables. So this means 4 times 3 plus 3 times, and we're going to multiply that by -1. I'm going to put that -1 in parentheses. Since there's no operation shown in between, that again means that it's multiplication, equals 9. Okay, so take a look at this. Do you see how this is the same equation as that, except instead of 3, or instead of x, I put the value for x, which is 3, and instead of y, I put the value for y, which was -1. But otherwise, this is just that equation copied down. So now we work through it. Order of operations, say I do multiplication first. If that's something you need to review, if that's not just like really second nature to you to do multiplication before addition, you may look for some review on order of operations. Okay, so 4 times 3 is 12. 3 times -1 is -3, so I have 12 plus a -3, which is the same as 12 minus 3, equals 9. So again, I've just rewritten this equation, but simplified those multiplications. Now I can do the subtraction. 12 minus 3 is 9, equals 9. And you may have gotten that even without writing that very last line, but you can see that is a true statement. So this first ordered pair, the answer to the question of is it a solution, is yes, because it made a true statement. Okay, so let's go ahead and check the second one. I'm not going to write out all the steps like I did before. I'm going to do it down here below because I don't have a whole lot of room over here to the right. 4 times x, which is -1, so 4 times -1 is -4, plus 3 times y, the y value for this ordered pair is 4. 3 times 4 is 12, equals 9. So our question is that a true statement? Okay, hopefully you're ahead of me and you know that it's not. -4 plus 12 is 8. So this is not. 8 equals 12, or 8 equals 9 is false. So the answer to the second one is no. And let's do the last one. 4 times the x is 0, so 4 times 0 is 0, plus 3 times 3, that's plus 9, equals, oops, my pen kind of gave out there for a second, equals 9. Is that true? Yes. 9 equals 9. So the answer to this last one is yes. Okay, so going back to this problem, we found 2 numbers or 2 ordered pairs that are solutions to this equation. But that isn't the only solutions there are. If we kept guessing and checking and trying different things, we would find there's actually an infinite number of solutions to this equation. Each time you change x, you can find a corresponding y that make it true. And that's not true for every equation, but that is true for this one. In fact, this equation, when you graph all of the points, plot those on the graph, they make a line. And we're going to later this chapter talk about how you know when you have a equation that makes a line, in other words, a linear equation. At this point, just know that this one is, and the next one that we're going to do in an example is as well. Once you plot all of these points, you can just connect them. You can, plot a handful of points, connect those, and you're going to have a line. And that's basically plotting all of the solutions, and that creates a graph that represents this equation. So this next sentence just says that to graph a solution or in solution, to graph an equation is to make a drawing representing the solutions of the equation. So let's do an example of that. We've got another equation here. This is another linear equation. Just trust me on that for now. We will talk about how you can tell it's a linear that makes a line. And we want to find solutions, and we're going to graph some of those solutions. And then since this is a line, once we have a few solutions, we can connect the dots, and we've got the graph of all of the solutions, because there's actually an infinite number of solutions. And so I'm just going to make a little chart over here to the right of x values and their corresponding y values. And I like to start simple. Use numbers like 0 and 1. Those are good starting points. -1 sometimes is good, or 2. But start with those small numbers and plug them in. So we're going to pick 1x, and then we're going to find the corresponding y. You could also pick a number for y and calculate the x. I'm going to start with x and find the y's, because the way this one is written, do you see how the y is over here by itself? Y equals, in other words, it's isolated. It's on one side of the equal sign by itself. That means if we replace the x, we can just do the arithmetic over here on the right side and we have what y is equal to. So I'm going to start with the simplest ever, which is 0. So replacing the x with 0, I get 2 times 0, which is 0, minus 4. 0 minus 4 is negative 4. So that's my first point. 0, 1, 2, 3, 4, down 4. I get a point right down here. Okay, let's pick another number. 1 is always a good choice as well, because when you multiply a number by 1, you just get the number. 2 times 1 is 2. 2 minus 4 is negative 2. So that's our second point. So 1 in the x direction, so to the right, and then negative 2. And I should be labeling here. I'm going to label this one. That was 0. And my handwriting is better than it looks. I am writing with a mouse right now. I tried using a stylus and didn't have good luck. I think I need a better one probably. So hopefully either I'll get better at this writing with the mouse, or I'll figure out something else as we go. I'm going to plot one more point, plugging in 2 for x. 2 times 2 is 4. 4 minus 4 is 0. And as you can see, these points lined right up. If you draw a line and you're going to keep going, and what that means is if you plotted a point in between, like in between our 0 and our 1, like if we did 1/2, you're going to get a point that falls right on this line that connects them. Same way up here, if we did 1.5, we find a point that's right on that line, and you can test that out. And if we kept going to the right, they would continue to be in this same pattern. And I'm not using a straight edge. If you have one handy, you might carry one around. It makes making these graphs a little bit easier. And that would just keep going. So even though our graph stopped up here at about, I think that's 8, 3, 4, 5, 6, 7, or 8, it's going to keep going. And we could have solutions. We could plot some points way up here, and they would also be right on that line. Same way in the negative direction. Okay, so we have now graphed this equation by finding some solutions and connecting the dots. And this one is a linear. We'll talk later about some other types of graphs. Okay, so plotting points is a great way to graph. There is another way, and that is using what's called the intercepts. And this is some definitions that you do need to know. The x-intercept and y-intercept. This is where your graph crosses the axes. So the x-intercept is this point right here. Let me highlight it right here. This point where the line that we just graphed crosses the x-axis. That's called the x-intercept. And then we have a corresponding y-intercept down here where the graph crosses the y-axis. And if you're graphing a line, you're just going to have one of each of those generally. There's a couple of exceptions that we'll get to later. But basically, you're going to have an x-intercept and a single y-intercept. And so let me just fill in the definitions here. An x-intercept is the point where the graph crosses the x-axis. So how would we find that? So let's take a look at that x-intercept up here that's highlighted in yellow. It's the point 2, 0. So something that you're noticing when you're doing the x-intercept, you're not going up or down. You're staying right there on line with the origin. So that means the y value is 0. So great way to find the x-intercept is to set y, and my tense here is a little different. So it's found by setting y equal to 0 and solving for x. Okay, so you're going to take the equation, our original equation up here, replace the y with 0, solve with x, and you're going to get 2. For the x-intercept, we're going to do just the opposite. We're going to set x equal to 0 and solve for y. So you might put a little asterisk out to the side when you're doing your homework. You're going to want to remember, and you definitely want to learn this and make this be something that you just naturally do, because it's going to come up quite often, not just with linear like we're doing right now, doing lines. We're also going to do this as we get into other types of graphs later this semester. This last little question down here, we already did this. Review the graph of 2x minus 4. What is the x-intercept? That was our 0, negative 4. And the y-intercept is, I said that backwards. The x-intercept is 2, 0. Let me erase that and fix it. Trying to write and think at the same time. Okay, and talk at the same time, all of that. Okay, so our x-intercept, we already said, is the point 2, 0. Y-intercept is 0, negative 4. And again, I'm listing those as ordered pairs with the parenthesis and the comma. Don't forget to put the parentheses around, otherwise it doesn't represent an ordered pair. You're not communicating clearly what those points represent. Okay, so now let's graph a new equation using the x-intercept. So instead of just plotting random points over here, we're going to plot the x-intercept and the y-intercept. For the y-intercept, for the x-intercept, you set y equal to 0. And for the x-intercept, you set x equal to 0. And then we're going to solve for the opposite ones. So let's start with the x-intercept, setting y equal to 0. I'm going to rewrite this equation, but put a 0 in place of that y. So I get negative 4 x plus 3 times 0. 3 times 0 is 0. Don't even need to write that down. Equals 18. So now I need to divide by negative 4. And that's going to give me a negative 4.5. You can write it as 4.5 or 4.5. So this point is in the x direction, negative 4.5. Right out there, and it's right on the x-axis, so I don't have to go up or down. Now doing the same thing for the y-intercept, replacing the x with 0. Negative 4 times 0 is 0, plus 3y equals 18. So I have 3y equals 18, y equals 6. So that's our second point. The x is 0, and I go up 6. 1, 2, 3, 4, 5, 6. And since I've told you this is a linear equation, and you'll know how to recognize them in just a couple more sections, we will draw that line through. And again, I would do a little bit of labeling, maybe label the intercepts just to be clear about the scale of the axis, that it's not counting by 2s or by 5s or something else, by 10s. 0, 6. This is our x-axis and our y-axis. Okay, that is it for this video. You can take a little break, or you can pick it up. You can just keep going if you're doing well. There is one more section for 1.1, so you'll want to watch it before you start on the homework for this section. So I'll be back in just in that next video.